initial melt on our 7-ton electric arc furnace. But there's a few features on the furnace I'd like to point out to you. The first and principal reason why we actually bought the furnace is the use of this jet box. This jet box will allow us to inject oxygen and carbon simultaneously while we have the power on. The carbon and oxygen will mix in the slag and create a foaming slag. This is really important for the next generation of steels and slags, and a part of the research which is required to produce low nitrogen steels in electric arc furnaces. The jet box is also equipped with a natural gas burner, which will allow us to preheat scrap within the furnace and hence reduce our melt out times as well. Hence also then saving electrical power. We won't just have electrical heating from electrodes, we also have chemical heating as well now in this new furnace. Some of the other features I'd like to point out to you is the new slag door. The new slag door is hydraulically driven, and interestingly it doesn't have any refractory on the actual door itself. It is just a water-cooled steel plate. However, this new design of door allows us greater access to have a look at the arcs actually happening, and have a look at how foaming slag is occurring within the furnace when we're using the jet box. This new facility, it's a larger door, more vertical than horizontal, which then gives a greater field of vision. On the right, we have the carbon feed hopper for the jet box. And it's very simple to use really in terms of actually adding carbon into the melt when required. On the left, this is our new material feed hopper then. It is constructed so that it's capable of charging HBI, DRI, iron units or composite materials, a bit like these, then in through the fourth port, which goes directly in between all three electrodes from the furnace roof into the hottest part of the furnace. The work we do here on plant is supported by the metallurgical labs and the state-of-the-art equipment available to us here at the Institute. We can undertake metal analysis and slag analysis, which are live to allow us to undertake modifications to both the metal and the slag all the way through our melting program.
I'm Dr. William Knapp, the Chief Science Officer at Cocoon. Today at the MPI we are testing some prototype technology which we are hoping to integrate into our pilot plant in the southern US. We use the MPI for testing our technology because they have world-class facilities like the 7-ton electric arc furnace behind me, which allows us to test our technology at the medium scale. So there's small-scale technology testing and also obviously large-scale technology testing, such as that on a live steel plant. It's very difficult to find facilities where you can test at the ton scale, so subject our equipment to long durations of molten metal activities at that kind of medium scale, and the MPI is perfect for that level of prototyping.
This new furnace will allow the Institute to undertake the development of new steels and slags which will be required within the steel industry in this country and around the world.